So graphically, I know it is an astrograph, but a graph of this, it goes up. Everything that goes up must come down. Boom, hits the ground there. We're looking for the vertex.
Yeah.
So if you recall, the formula for the vertex is minus b over 2a. Now, just kind of thinking ahead to your final exam here, do you know if you will get a reference sheet or you'll get a sheet that you can bring in for?
Probably.
Okay, this might be a good thing to put on there, right? You've probably seen me boxing and stuff for a while. Always, maybe even if you don't know if you're gonna get one, might be good to just write some things down and see kind of where you stand on that front. Okay, so in your problem, A is minus 16, B is 48, C is 3. 3, not that letter. Would you calculate the minus B over 2A for us, please?
Sure. Uh, 1.25.
Okay, yeah, so minus 48 over 2 times negative 16 ends up being 1.25. I agree. I do not agree. Apologize. You just double check that one more time. It's 48 over 32.
Yeah.
Should be just 1.5.
Oh yeah. I
Okay,
see.
now that is just like when it opens. That's just the time. That's just okay. That's just
Yeah.
where it happens. So to actually get the height, you have to put 1.5 back in for t. I know we called it x. That's just the general form. So you're going to find s of 1.5. And notice that I'm putting it in parentheses when I substitute. Recommend doing the same. And if you want to grab a calculator and work that out here, I'll confirm your answer.
All right. I got 39.
You're good. And then you just want to make sure you put the units in. For example, the time, we didn't do a good job. It's my fault. It's 1.5 seconds. The distance off the ground is in feet, so it's 39 feet, like that.
Yeah.
All right, so that's this first question. What's the maximum height that'll reach? You have to find the vertex, both the x and the y. Now, when will the ball hit the ground? That's graphically, whatever goes up must come down, hits the ground there. So we're setting the minus 16t squared plus 48t plus 3 equal to 0.
Yeah.
And there's a couple of ways to solve this. You could try factoring. I don't believe this factors. You could try completing the square. That's not going to work out real well. You probably are going to go to the quadratic formula, or like I said, you could just graph it and find that. Are you allowed to just graph it, or do you have to show your work, do you think?
Usually have to show our work, but if there is
Okay.
a graph, we usually graph it.
Well, let's since we haven't done quadratic formula in a while, let's do that. It's kind of an in-between. All right.
All right.
So from here, we've got opposite of b. So minus b plus or minus the square root of b squared minus 4ac all over 2a. And then we just start substituting the numbers in. So it's minus 48 plus or minus the square root of 48 squared minus 4 times minus 16 times 3 all over 2 times minus 16. This part under the root's the most important one. That's the one where most students have issues. It's just because of the size of the numbers, the fact that there's negatives and positives. You know, we spent a lot of time talking about that. Will you try calculating that for us, please?
Sure. Got 3.06.
You're talking about for just the part under the root, right?
Oh, yeah, I get that.
Not the whole thing. We can do the whole thing, but not get.
Okay. Uh, 2,496.
Yeah. So it's negative 48 plus or minus the square root of 2,496 over negative 32. And you know, if you're comfortable, you just enter all this into the calculator. It is kind of you're kind of splitting it apart though, really. It's this first part where you're adding it and then dividing by negative 32. And then you're also trying the other one here. And you maybe wonder, why do I need both? Well, one of them is the one where it actually hits. The other one is this kind of extraneous place over here to the left where it doesn't exist in the physical problem. So you have to try both of these until you get the one that you want, meaning like the one that's positive. Is that
Yeah.
clear, or is that
Yeah, that makes sense. I got
okay?
90 or wait, 1.96.
You got a different number. Are you using the Desmos Scientific or something else? Wait,
Oh wait,
maybe I got the wrong. Nope. Yeah.
no, it's me.
Yeah, give that one more try. It's the one on the right here that worked.
You got 3.06.
And that's in time, so it's 3.06 seconds.
All right.
All right. That okay? Kind of feel like you get knocked all the stuff there.
Yeah.
Okay. Number two here. All right, number two, they're asking about transformations. So the parent function, like going back to one of our earliest lessons, the parent function is x squared. Okay. there's two things that I see here that are modifying the parent function. It's this negative in front, and then this +4. So
Yeah.
it's that negative x squared. It's like, what does that do? You can always graph it if you're unsure. Okay, and let me do that real quick here and snip that in, because if you're on a test and you're like, I don't remember, or I'm stressed out, you graph both of them, like y1 and then y2, or if you can use Desmos, snip that in here. We should put it down here. Oops. Sorry for all the moving. Get this right here. Okay. So what I've done here is the black is x squared, the red is minus x squared. Visually, you can say, okay, it's reflected over the x-axis.
Yeah.
Right. So that's what they're looking for. Reflection over x-axis.
Yeah.
Right. Now, for this other one, this +4, here's what you can do again. And I'm gonna do the graphing here again to show you that. Let's snip it in. So I'm graphing. I graphed minus x squared in red, just like before, and then minus x squared +4. Notice I'm just adding one transformation, and you should say, oh, it's just moved up 4 units.
Yeah.
So if you can graph them one at a time, you get 4. You could say, okay, it's up 4, or it's called a vertical translation. Up 4. Down. You could, and then
Yeah.
so that's what they're looking for. This. I don't know. Does that make sense? We got one more that's kind of like it to do, but
Yeah, that makes sense.
there are other transformations or not kind of incorporating into this. I don't want to say, I don't want you to think like we've got an exhaustive list, complete list. We've just done the ones that they're putting here. So, okay. 2x squared minus 7. There are two transformations again. There's this 2 in front of the x squared, and then there's this minus 7. Can you tell me what the minus 7 does? Because it's really similar to that +4 we had in the previous problem.
It's down 7.
Yes, really good, really good. Any idea what the 2 does? Or if you're not sure, I'm happy to graph it to show you as well.
It's like the slope.
It would be if it was a linear equation. We got a. So let me graph it here.
The left and right.
That's the other one. That's inside parentheses. So like if it was like x minus 3 or +3, that's left or right. So let me show you here. Picture's worth 1,000 words, right? Or that's a book cover. I don't know.
Yeah.
So the purple is the green that's pulled up. So literally, like it's like you pick a point, and it's like pulled up.
It's like tighter or
Well,
wider.
it's like by the letter of the rule, the letter of the law. It's called a vertical. It almost looks like it is squeezed in horizontally. Like if you think about width, you'd say, oh, it's narrower, which is true, but the correct answer is that it's a vertical stretch by 2.
Yeah.
Okay, you want me to do any more of transformations or just keep moving on through this?
Just keep moving on.
Okay. All right, so, ooh, wow, a lot of stuff here. Be able to find the mean, median, and mode, min, first quadrant, approximate, data, okay. Middle 50% data. We do that, okay. We should pick one data set, but not all of them. We just wouldn't have time. Is there one that, the easiest one to do by hand is the last one there, the number of siblings that a person has? But we can do, if we're allowed to use a calculator, we can actually do all of them.
I do number of siblings.
Okay. And when I say calculator, TI-83 was what I mean by that. So first order of business is to put them in order. So you'll notice that I cross them out as I consume them. Looks like there's 2 1s. And then there's 2 2s. And then there's 2 3s. And then there's 2 4s. And then there's 1 5. Also a good idea to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then make sure you have 10 in your new list.
Yeah.
And you do. Okay. The median is the middle number, but this does not have a middle number. This has 2 middle numbers. You have to find the average of the 2 middle numbers.
Yeah. And that's 2.5.
Yeah, so your median, you kind of want to do that off the side. Your median is 2.5. Now, because it's an even number of numbers, you actually split the data right in half, and you look at the left half and the right half to find quartile 1 and quartile 2, quartile 3. You're finding the median of each of those. What would that be in this case? What's the middle number?
1 and 4.
1 and 4. The last is the min. The min is 0. The max is 5.
Yep.
Okay, so if we go back to, like, if you read, I'm sure you got this paper in front of you, it says be able to find the mean, median, mode, min, max, range, mean, absolute deviation, first quartile, third quartile, IQR. We're going to get to all of them, but like this is the 5-number summary. This is kind of your baseline. The IQR is the Q3 minus the Q1. So 4 minus 1. The range is the max minus the min.
Yeah.
Again, notice like all of this comes from the 5-number summary. Like there's a reason we do this first because we get a lot of other stuff from it.
Yeah.
Usually from here, you'd go to do the box and whisker plot. So I'd like to do that next. We'll come back and do the mean, the mode, and the MAD, mean absolute deviation. So with the box and whisker plot, you start with the median. You just arbitrarily, like, I'm going to call that 2 and that 3. I'm going to put a vertical line right there at 2.5. And then you go right to Q3 or left to Q1, either one there. There is nice symmetry on this one. So that's Q3. That's Q1. And then you draw out to the max. And then you go to the min as well. This one does not have any outliers. I'm just going to say that. I believe the second data set does. So we might be able to look at that next.
All right.
But that's your box and whisker plot. I'm talking about outliers. All right, so now we can do mean. So that is the sum of the numbers. Gonna add them all up. And then divide by the number of numbers, right? So you got to add up all those numbers. You can go back to the original. You can use the ordered data set. Would you calculate the mean though of this data set for us, please?
Yeah. Uh, 2.5.
2.5. It ends up being 25 over 10, which is 2.5. The mean can equal the median. That's okay. The next thing is the mode. There can be more than one mode, and you're looking for numbers that appear more than once. That's another reason to do the ordered list. Makes it easier to see all the ones that appear more than once. So notice that 1 appears twice, 2 appears twice, 3 appears twice, and 4 appears twice. So there's actually 4 modes: 1, 2, 3, and 4.
Yeah.
All right, so have we answered everything? Mean, median, mode, min, max, range. Nope, we have not done that. Any questions on any of the formulas? Anything we've done up to this point?
No.
Okay. So the MAD you get from taking each data point, each sample, and subtracting it from the mean. So let's just start with the first data point, 3. So I'm doing this in the order that it appears. 3 minus 2.5 absolute value equals 0.5.
Yeah.
Next one is 2. Absolute value 2 minus 2.5 equals 0.5. 1 is 1 minus 2.5 equals minus, oops, sorry, absolute value 1.5. 0. Does this look like what you guys were doing in class?
Yeah.
Okay. Now, just because I don't have the room, I'm going to write a little smaller, but then I'm going to go to another column here. So 4 minus 2.5 is 1.5. And then we just keep going here. So you got a 2. 2 ends up being 2 minus 2.5, 0.5. 4, absolute value 4 minus 2.5 is 1.5. 1 is absolute value 1 minus 1.5 equals 0.5. And then 5 minus 1.5 is 3.5. And then last one there, 3 minus, whoa. I'm sorry. I got where I stopped that doing this correctly. 1.5, 1.5, 0.5. Okay, so once you get all those numbers, you unfortunately have to find the average of those. So you got to add them all up and then divide by the number of numbers. So it's a little bit of work, but this is 1. 1 plus 1.5 is 2.5, plus 2.5 is 5, plus 1.5 is 6.5, 7, then it gets 8.5, 10, looks like it's 12. So it ends up being 12 divided by 10. 1.2.
Yeah.
Okay. The only other thing that I've not done is to be able to find the middle 50% of the data. I'm just looking through it again. So the middle 50% is always from Q1 to Q3.
Yeah.
All right, so let's quickly look at that middle data set because there looks like there's an outlier, and I want to at least show you how to do it. The other one might have an outlier, but I think this one for sure has one. This is real positive. Grades of students in class. Not. Okay, got to put them in order, right? Got to start by putting them in order. So 24, comma. Now, sometimes it's hard to find an order, so you could leave some space in between them. Where you just, really be sure. That looks like maybe 54 is next. 62, 71, 75, 76, 84, 92, and 97. So this is the same number of numbers as the first problem. I'd like you to find the median, Q1 and Q3. And if you need me to scroll back up to show you how we did that before, I can, but it's just like the first problem, but just different numbers.
Uh, 73.
For the,
Oh, for the
what is it?
median.
Yes,
For
thank
the
you.
median.
Very good. How about for Q1?
Uh, 54.
Okay, and Q3?
84.
So actually take this back. This one does not look like it has any outliers. That's okay. So the next thing is to find the IQR. Could you do that for us, please?
Sure. 30.
It is 30. It is 84 minus 54, which is 30. Now, to find outliers, you have to do what's called the upper fence and lower fence calculation. So the upper fence is Q3 plus 1.5 times the IQR. So you have enough to be able to calculate this. Could you try that for us, please?
Sure. 129.
Yes, it ends up being, like you said, 84 plus 1.5 times 30, which is 129. So the upper fence is like, you're like, are there any values above the upper fence? And the answer is no, there are not. The lower fence, it's a similar calculation. Q1 though, minus 1.5 times IQR.
Yeah. Let's see. Nine.
Okay, that sounds right. 54 minus 45, which is 9. So you're like, well, are there any values below 9? So when I first said, hey, I think it's got an outlier, I was kind of looking at this 24, but it does not appear that it does. So this one actually has no outliers.
Oh,
All right, so let's look at kind of the last question here. Well, before I do that, any questions though on this? This is just kind of an addendum to what we were doing earlier.
no questions.
All right, very good. The sometimes they give you a box plot and they say, well, I want you to interpret some things. They want to get you to give them some numbers or some answers. All right. And for example, we can just do the same thing. I could ask you for the min Q1, the median Q3, and the max. Could you give me some of those values?
Sure. So the minimum is 19. Q1 is 21. The median is 22. Q3 is 24, and the max is 25.
All right. So IQR, what would that be?
Three.
It's 3. It's 24 minus 21 is 3. That represents the middle 50%, but you have to express it as a range, 21 to 24.
Yeah, okay.
Now, sometimes they ask kind of like, they're not trick questions. I don't really like that. I mean, we're not doing magic here, but with time, sometimes it's weird because it's counterintuitive when we're used to certain things. If it asked for what how do I say this? What was the fastest time? What would you say?
19.
19. Now, what do you think? Is that slow or fast? Average?
That's pretty fast.
Okay. And then we could also ask for the slowest time, right? That would be going the other direction. That's the 25 seconds.
Yeah.
They can also ask you things like, what is the bottom 25%?
19 to 21.
Yeah, so there's trying to get the highlighter here. There's 3 25%. So that first one, there's that next one, there's this next one, and then there's this one. So there's 4 25%. It could ask for really any of them. Could say, like you said, it's 19 to 21 seconds. Very good. Some things that you cannot do with, like, sometimes like they ask you questions about what, like, what can you not find? Here's some things that you cannot find with just the box no script plot. You don't know the average. So unless you have all the data, you cannot find the average. You also don't know the total number of scores. Right? You don't know whether there are 4 scores here or 400.
Yeah.
You also cannot find the MAD, the mean absolute deviation. Like if you need the average, you sure can't find the mean absolute deviation.
Yeah.
You also cannot find the mode, because you don't know which score is the most common. You just know the summary of the scores. All right. So if you have time, if you feel compelled, you're more than welcome to obviously work on this problem, night or before your test. But that is going to do it for us for tonight. We do have a lesson scheduled for Thursday.